So now this will be question number 4 of the worksheet. So a woman stands on the bank of a frozen lake with a dog by her side. She slides the bone across the ice at a speed of 3 meters per second. The bone slows down with deceleration. The bone slows down with deceleration 0.4 meters per second square, and the dog chases it with acceleration 0.6 meters per second square. How far out from the bank does the dog catch up with the bone? Okay, so basically let's say this is the bank and this is a lady here. She throws a bone across the ice, this size. So the bone as it's traveling like this, and naturally due to some friction on the ice it's slowing down. But there is a dog over here also, so the dog is actually accelerating. Dog will accelerate to catch the bone. Okay, so the deceleration of the bone is 0.4 meters per second square and the acceleration of the dog is 0.6 meters per second square. So let's say at this point the dog and the bone, they actually, that is, the dog catches the bone. So for both the bodies, that is the dog and the bone, the distance is the same, and as soon as the bone is thrown, the dog starts running also. So for both of them, the S will be the same, and the time of this motion, that is also going to be the same. Okay, so for the bone, let's use the formula S equal to ut plus half at a square. Why? Because we don't know the final velocity actually. Okay, so S is equal to, for the bone, the initial velocity is 3 ut, and actually half, the value of A is minus 0.4 since it's deceleration, so minus I am putting over here, half A. So this is minus, the value of A here is minus 0.4, but the minus I am putting outside. Okay, this is for the bone, and for the dog, the value of S will be the same and the time will also be the same. So the initial velocity of the dog is 0. So u is 0. You just have half A is 0.6 for the dog, t square. Okay, now this is S and this is also S. So I can write this 3t minus half 0.4 t square is equal to half 0.6 t square. Okay, so this is a quadratic equation which you have to solve. So after solving it, actually you will get two values of t, that t is equal to 0 and t is equal to 6. 0 is quite obvious because if you look at the equation, there is t. So if I put the value t, both the left hand side and the right hand side will be 0, and logically also you can actually see that the value of S initially when t is equal to 0, both of them, they have traveled 0 distance. Okay, they are at the same place, their displacement is the same, and also when the dog catches the bone, their displacement is the same, and that is the time that we are actually looking for. But the question is asking for this, is asking for the value of S. So S, in order to find the S, we can put the value of t, that is this one, in any one of the equations. So let me put it here, half 0.6 6 square, and the value will be 10.8. So the answer is 10.8 meters. That is the distance where from the bank where the dog catches the bone. Okay. So the last question, that would be question number 5 in your worksheet. Now we'll solve question number 6 in the worksheet. So here the question is, a man is running for a bus at 3 meters per second. When he is 100 meters from the bus stop, the bus passes him going at 8 meters per second. If the deceleration of the bus is constant, at what constant rate should the man accelerate so as to arrive at the bus stop at the same instant as the bus? So if you actually visualize, so what's happening over here, let's say the man, so man is 100 meters from the bus stop. So now the bus crosses the man. So when the bus crosses the man, actually it starts to decelerate. So we're assuming constant deceleration. Why? Because when the bus will reach the bus stop, the deceleration will be such that the final velocity of the bus is going to be 0. This distance is 100 meters. And the speed of the bus is 8 meters per second. And the speed of the man is 3 meters per second. Okay. So we want that the man and the bus, they arrive at the bus stop at the same time. So we're actually assuming that the man is constantly accelerating through this journey and the bus is constantly decelerating. So for them, the distance traveled from this instant will be the same, 100 meters. And the time taken from the bus to come from here to the bus stop and the man to come from here to here is going to be the same. So they are traveling the same distance in this time interval, in this distance. So they're traveling the same distance in the same time. So and all of them, they have constant acceleration. One is accelerating, one is decelerating. But you can say that their acceleration for each body, it is constant. Not same, but definitely constant. So their average velocity is going to be the same. Their average velocity will be the same. So let's say the final velocity of the man is Vm. And the final velocity of the bus is 0 meters per second. So you can actually write you can use the formula that average velocity is u plus v by 2. See, this is the initial velocity of the man. The initial velocity of the bus is 8. So the value of Vm is equal to 5. Okay. So now we have to find the acceleration of the man. So let's use v square is equal to u square plus 2as. So v square is equal to u square plus 2as. So the value of a is 0.08. So the acceleration of the man is going to be 0.08 meters per second square. Okay.